Hey everyone, good morning. Okay, let's start with today's session. Very interesting topic we're covering today. That is now, what do you know about Kubernetes, guys? Like, what are your understanding? What exactly is Kubernetes? How different it is from Docker? Can anyone try explaining me? What do you know about Kubernetes, guys? Anyone wants to try? What exactly is Kubernetes? How it is different from other container services? And what is Kubernetes basically? No one? Josh? Who else are there? We got very limited people. Only three. Very good. Okay, no problem. Let me take this further. Now, Kubernetes is basically it's an orchestration tool. Now, what is orchestration tool? That is something we'll understand. Okay. Before that, let me. So, before you understand container management, the term container management. Now, from where did this container management came in picture? Now, as we are moving into the microservice world, wherein we are deploying everything in as a microservice application, just imagine the number of containers getting increased. Like imagine if you have around 4 5 containers, that then you can easily manually see which container got stopped. You can inspect why exactly it has stopped. You can go and rerun the container. So these all things you can do manual if the numbers are small. If it is a 4 5 containers, maximum 10 containers. Just imagine if your company there are more than 1,000 containers running. Is it possible for you to go and manage those manually and monitor those container manually? And if something happens to any of the container, uh, go and rerun the container manually. Correct? That's quite not possible. Or else if you need to have 4 5 people just to see if all the containers running. So management becomes very difficult task. Eventually, when you grow in microservice world, management of container becomes a very difficult task in real time. Okay, this is the biggest issue what we have faced when the microservice environment grows. When your microservice environment in your company grows, this is the biggest task which you face: management of container and adding new containers, like creating new, deploying new, scaling the containers. If something happens to your application, you want to auto scale your container. So these were the difficult tasks which we had faced. So this issue was fixed with the container management tools. Now, what is container management tool? Container management tool is basically a process for automating the creation, deployment, and scaling of containers. So it will automate the process of creating your containers. You don't need to go and do things manual. Scaling your container and deploying things on your container. It can also facilitate addition, replacement, and organization of containers on a large scale. So automatically adding new containers, replacing existing containers, and organization of container, organizing the container on a large scale. This is what container management talks about. Now, what is container? So as we all know, we have seen in Docker, container is nothing but it's a lightweight package that bundles together a single app and its dependencies to make application easier to develop, deploy, manage across IT environment. So it's nothing but it's a lightweight package that bundles together. It has a single app with all its dependencies and library, which makes easier for you to develop, deploy, and manage across complex IT environment. These are some container runtime engine what you have in the market. You got Docker, Containerd, CRIC-O, Arclet, Kubernetes, CRI. These are container runtime engine in which we have seen Docker, how Docker works. Correct? Now, what are the benefits of using container management tool? If you have a container management tool, what are the benefits? First, it will help you deploying your application very easily. It can help you deploy your application. It can auto scale automatically. So if there's a load in existing container, it can automatically spin up more containers for you. It can roll back and can roll out. It can automatically roll back and roll out your changes. It can do batch execution. If there's any batch execution, like a bulk deployment kind of thing you want to do, then it can also do that for you. It can also do load balancing, balancing your traffic between multiple containers. It can do that for you. It can also help you monitor your container health, whether all the containers are working, application is running, and things like that. It can do that for you. And it can help you schedule. So basically, if you want to schedule any container at some specific time, so it can do that for you as well. Followed by, so these are few benefits what a container management tool should have. Okay, so it can help you deploy, schedule, auto scale, monitor, load balance, batch execution, rollback, rollout. These are few benefits what you will have with container management tool. Okay, some well-known container management tool which is there in the market is Kubernetes, Docker Swarm, Apache Mesos Marathon, and OpenShift. Okay. These are some well-known container management tools. So Kubernetes is what? It's a container management orchestration tool. Okay. Now what exactly this word orchestration is, that is something we'll understand. But along with Kubernetes, we got Docker Swarm. This is a in-house. If you're using Docker, then you got Docker Swarm also, which can help you with container management activity. We got something called Apache Mesos Marathon, and we got OpenShift. OpenShift is just the GUI version of Kubernetes, guys. OpenShift uses Kubernetes in the backend. So if you know Kubernetes well, OpenShift it's not that difficult task for you, because it's just a GUI version. It's a web-based, wherein in the backend it is using Kubernetes for you. Kubernetes, like at stretch, if you ask me, it's a difficult tool to learn. But if you know it, it's a well and good. But so that difficulty which you have with Kubernetes, OpenShift has resolved it by giving you a GUI. You just have to click, and you will have your pods and environment ready. Okay, so if you know Kubernetes well, you can easily work with OpenShift. Just keep that in mind. So what exactly is Kubernetes? Kubernetes is a container management orchestration tool. Now, what do we understand with this word orchestration? So orchestration is like orchestra, correct? Like suppose there are 100 musicians and you got a person in between who is just waving his hand with the two sticks, and it's so waving his hand, what exactly? He's doing a time pass? No. So he's directing the musician what music, what rhythm needs to be played. And based on his direction, the musician are playing all those instruments in a way, in a sync manner. So that person in between who is just waving his hand is orchestrating the entire 100 musician. He's making sure that the right music, the right tone is getting generated. So that wave itself is orchestrating the entire 100 musician what needs to be done. That is what Kubernetes does. So just imagine Kubernetes in the center, and with the help of Kubernetes, there are 100 containers which getting created. Now, Kubernetes is basically guiding where the application will be deployed, how the application will be load balanced, how the rollout will happen, how the rollback will happen, how if something happens to the container, how the replacement will happen. All this getting managed centrally from Kubernetes. That is why we call it as orchestration tool. Make sense? Why we call it as orchestration tool? Along with Kubernetes was developed by Google. So Google has developed Kubernetes before, but later they have donated this to CNCF. CNCF is nothing but it's a cloud native computing foundation. So it's a firm where all your open source tools are listed. So basically CNCF has a very big community, guys. These guys have very big community of open source developers. So if any tool comes to them, then that becomes open source. Kubernetes is free to use. You can go and get the binaries. You can use it the way you want. Okay. Now that is one of the reason why Kubernetes is so popular nowadays, because if suppose Google has it, if only Google is using Kubernetes will not be so overwhelmed used, and Google would have put many restrictions, and it could be enterprise version of Google, and it will, because Google has limited set of developers, so Google may not enhance Kubernetes so much. Now in open source world, what's happening, there are thousands of developers throughout this world, and they keep on adding something, keep on adding some features, some packages, some bug fix. They are on a daily basis they are doing it. So that is the benefit if something becomes open source, and that is the whole reason why Kubernetes is so popular nowadays. Just imagine if it is with Google. If Google is spending a lot and having X number of developers to build the tool, then that's a different story. For now, because it is open source, that's why it is more popular. Okay, it is open source, it's free to use, and it is written in Golang. Okay, also known as K8. K8 because in between there are eight words and starting with K, ending with S. So it's K8. So this is what Kubernetes is all about. Now there are many features. So some of the features I have listed in my PPT, guys. It's not possible for me to list every feature over here. So just an overview. These are some features what Kubernetes provide, which makes Kubernetes very unique and very good tool to work with. So features such as automated bin packing. The automated bin packing means it will automatically package your application and schedule the container based on requirement and resource availability. Okay, so if you have Kubernetes setup done, I'll talk about Kubernetes architecture in a bit. But if you have Kubernetes setup done, or you just need to write the configuration and give it to Kubernetes. Now Kubernetes will decide where this particular container will be created based on resource availability, and it will automatically package your application. It will go and deploy your application at a running container based on resource availability. Service discovery and load balancing. Service discovery can control over network and communication between pods and can load balance across them. So Kubernetes has an internal features of load balancing. It can automatically load balance the traffic, your application traffic between multiple pods. Now what exactly is pod? That is something we'll understand later. For now, just imagine it's a container. Okay, so it will automatically balance your uh, traffic across multiple containers. Just keep that in mind. Storage orchestration. So for making, like in Docker, remember the volume was not persistent. For making the volume persistent, what we were doing, we were mounting it on a local hard drive. That is what we were doing. Same way we can even mount it on S3, and as I said, you can mount it on Azure storage and things like that. Same goes with Kubernetes. Kubernetes by default the volume is not persistent. If you want mount, you can mount it on AWS, S3, Azure, your local hard drive, even that is possible. So Kubernetes supports those things, auto mounting. It allows you to mount the storage system of your choice wherever you want to mount. So it's the same thing, you can do it in Kubernetes also. This is a very important feature, self-healing. If the container fails, it will restart the container. It tries to, if any of your container is failed, Kubernetes will try to restart your container. Or this is done automatically. You don't need to go and look into it. If a node dies, node is basically the VM on which your containers are running. If the node dies, it will try and replace and reschedule the container on other nodes. So suppose on the particular VM there are 50 containers running, and if that VM itself has some issue, like some patching issue, it got rebooted, restarted, so it will wait for some time, or else it will replace all those container onto a different running node. Automatically this will be done. From one VM, all the node containers will be shifted to other VM. The only thing you have to make sure that you have auto scaling enabled, and you, in such cases, you should have other VMs available. If you don't have VMs available, what will happen? Nothing will happen. Okay. So if you have VMs available, then this can be easily done. The third part is if the container does not respond, the user defined health check kill the container self-healing. Now you can also have flexibility of giving some user defined health checks. What do I mean by user defined health check? Like suppose you want to make sure that each 5 minutes there are pings happening on all those containers, making sure that all the containers are running. So you have some user defined health check that I want to ping the following container at every 5 minutes. So just to make sure the containers are up, and you have defined such health check. Now, if your container is not responding to your health check, it will kill that container and it will create a new one for you. This is all self-healing feature happens automatically by default. That is the nature of Kubernetes. Okay. Now we spoke about automatic rollback and rollout. That is again can be done with Kubernetes. Rollout basically it will deploy changes to the application or its configuration. Rollback, if any changes, whatever you have deployed has some issues, and if you want to roll back to the previous version, the previous stable version, even that is possible. Kubernetes also talks about zero downtime. So while deploying, no downtime. So Kubernetes has multiple deployments strategy in which one of the strategy in which it says zero downtime. So that strategy is known as rolling update. Just keep that in mind. Rolling update is a strategy in which Kubernetes suggests zero downtime. There's no downtime at all. Like if you have an application running, so what exactly this rolling update is, just imagine you have an application running into 4 containers. Like you have 1 container, 2 container, 3 container, 4 container. So you have your application running on this 4 container. So how this zero downtime is achieved, let's see that. Now you got some version 1 installed on all these containers right now. Now there is version 1.1 which needs to be installed. So Kubernetes, what it will do, it will target this machine first. It will get you 1.1 on it, followed by all this machine is still serving 1 right now. So your client may receive the new feature. Some of the client may receive the new feature, some of the client may receive the old feature. Once this is done, once Kubernetes gives you a green flag that things are looking good, Kubernetes will deploy this now on this machine. Now this will get replaced by 1.1. Then it will do the check. If things are looking good, then eventually it will go to this machine, 1.1. Then eventually it will go to this machine. This is how zero downtime is achieved in Kubernetes. This is called rolling update. Understood how this zero downtime? So one at a time, this gets replaced. It can also do grouping. You can do this 2 pods first, then this 2. Even that is possible. It's up to you how you want to do it. This is what zero downtime is achieved. That means there's no downtime and your application will be up 24/7 and still you're able to deploy changes. Unlike traditional method wherein you have to take a downtime of 6 hours, 8 hours, shut down everything, shut down your application, impact your business, and then do the deployment. No, that days are gone now. In microservice world, there's no downtime. Have you ever seen Amazon.com going down? Any given point of time. Have you ever seen Amazon.com going down? No. They don't believe in downtime nowadays. It's zero downtime. No downtime at all. And still there you will see new feature every day on these big websites. How? With such features. Okay. So Kubernetes can also help you store secrets like password, token, your private key, public key. Those things can also be stored. So Kubernetes also store all this configuration inside the database what they have as an object. So this is basically all about Kubernetes and the feature. If anyone has any questions, any concern, please do let me know. Anyone? Any doubt, guys, with what is Kubernetes? Any So you can let me know before we move on to the architectural part. No questions? Okay. No. Yeah.
So, just a quick one. So, when we're covering the automatic rollout and rollback, is
Mm-hmm.
that was the rolling update the general term, or does that cover is it Canary and who's the other one? Like the different types of deployment strategy, or is that
Mm-hmm.
something different?
Yeah, there are multiple deployment strategies. So rolling update is a default strategy what you get in Kubernetes, and this is the best strategy which you can use it.
Okay.
So rollout and rollback means like basically suppose you have deployed version 1.1 on this system. Okay. Now you have found out there's some bug, some issues. Now this will automatically go back to one again because one was a stable version. So this will get removed automatically and this will be deployed again. That is what rollbacks means. This is this part. Rollout and rollback means. Okay. Now this is again done automatically, guys. So there are multiple strategy in Kubernetes. You can rolling update, rolling deployment, one strategy. You can have blue green, you can have canary, you can have AB, you can have shadow deployment. So depending upon what project you're working, what type of project, you can have those strategies defined. Okay, depending upon the use case, it's completely dependent upon your use case. You cannot decide what strategy upfront. Your company's use case, your application, what is the type of application. Now, suppose your application is not supporting zero downtime. It's a legacy one because zero downtime is a big thing, guys. Like if you want to run two versions of your copy at a time, that means your application should support backward and forward compatibility. Is your application supporting backward forward compatibility? That's the biggest question now. Now, such things have no. Now, this is something at the architectural level we decide when we design the architecture, how my application will be deployed, how my application will look like. That time we decide all this. You cannot just simply go, no, I will follow blue green. No, that's not possible. Is your application capable of blue green? Because what happens blue green, the complete application gets shifted. Now, in between, if there's some database transaction going on, what you will do? So all this if and but needs to be answered before even thinking of some strategy, guys. So it's a big discussion. There are architectural people who comes in picture and they design the complete application. At that time, all these things are decided. Okay, let's go back and let's see the architecture of Kubernetes, how Kubernetes looks like, what are the important components of Kubernetes, and then we'll go and set up this Kubernetes from scratch. Okay, so let's go and see. So basically I'm taking an example. This is a master node. This is a VM, guys. So basically this is a virtual machine. On this virtual machine, we call it as a control plane. Why do we call this as a control plane? Because all the services which will control the working of Kubernetes gets installed on top of it. Okay. So these are the services, what you see, these are the services which gets installed on your master node component. You can call it as master node, you can call it as control plane. It's up to you. This is one of the same thing. Now these are the component API server. So what is the role of API server? So API server is a component of Kubernetes control plane that exposes Kubernetes API. So all the calls, if you want to connect to Kubernetes master node, and if this master node needs to connect to someone, then all the calls happens through API server. Okay. Now HCD is nothing but it's a consistent and high available key value store used in Kubernetes. So this is basically the database of Kubernetes. Right? It's a consistent and high available key value pair database which Kubernetes uses for storing the secrets and storing the config map. So these are the components which is installed on your master node. followed by control manager. Now this control manager has multiple controller. It got node controller, it got job controllers, it got endpoint controllers. So basically managing the entire Kubernetes for you. For node control will see if the node is up and running, and if the node needs to be replaced. Job controller will make sure that the pods are created on a particular available resources. Endpoint controller makes sure that the services are available. So this control manager has multiple controllers which is running it. Then we got something called scheduler. Scheduler is basically is a control plane component, watches if any newly created pods and making sure the resources are available and making sure that pods are created in the right place. Okay, so it will look for newly created pods. Now what is pod? I'll cover that in a bit. So this will look for newly created pods and it will assign the right node to it. Okay. Cloud Control Manager is basically if you want to connect to cloud storage such as S3 and all. So at that time we'll be using this Cloud Control Manager. So this is one of your component. This is your master node, and followed by you got these are your worker nodes, guys. These things which you see, these are your worker nodes. Again, this is a VM. So basically this is one VM wherein your Kubernetes services are running. These are worker nodes where exactly your application will be deployed. Okay. Now the worker node has again multiple things, like it got container runtime. Just imagine Docker. Docker is running on the worker nodes. You got kubelet. Kubelet is basically an agent that runs on each node. So this kubelet service will be running on each node. Okay, it makes sure that the containers are running in a pod. So this is responsible for making sure that your containers are running on your worker nodes. Kube proxy is basically it's a network proxy. So this kube proxy will help you communicate with each other. Now if there are multiple containers running inside this worker node, the communication happens using kube proxy. And if you want to communicate with other nodes, so all this communication gets established using this kube proxy. So there are so many C's. That's why I said setting up Kubernetes is not an easy task. There are so many components are running on a master node. There are so many components are running on a worker node right now. This is how Kubernetes gets set up. That's why you have this AKS, GKS, EKS. These are all what? These are all cloud services wherein all this setup is already done. The only thing is you just spin up a node, a worker node, this worker node, and what happens? Your management node is already managed by the cloud providers. You don't need to do anything over there. That's why these all tools are very famous, because managing and maintaining all this becomes a very tedious task. Okay, now this is what an architectural diagram, this is how a Kubernetes looks like. These are the important components which runs on Kubernetes. Okay, understood, guys? Anyone, any question? No question? Now let me explain you this architectural diagram again in a very layman term, because I know this kubelet, kube proxy, I know no one would have understood anything. Let me explain you this with a simple example. Now think of a aeroplane. Think of a aeroplane. Aeroplane is your, imagine that's your worker node. Aeroplane, the example which I'm giving, that aeroplane is your worker node. And think of ATC, air traffic control. ATC is your control plane. Okay, ATC is your control plane and your aeroplane is your worker node. Kubelet, in that aeroplane, kubelet is your pilot. Kubelet is your pilot. Okay, now if the aeroplane wants to land on Mumbai airport, for example, what he does, he will reach out to the ATC. How the communication is happening? The communication is happening over the telecom, whatever they have, the signal calls they do. So the API call is happening. Just imagine there's a API call happening. Now the API call, the pilot is calling the ATC, asking landing permission, that I want to land, which runway is empty, and where do I land. All this permission, because kubelet cannot decide where to land. Okay. Now the API receives the call. This gets sent to the control manager, the person who is sitting on the phone, the person who has the rights to decide where this uh, particular aircraft will be landed. Now the person goes and checks the availability, which runway will be empty at what time. So the person goes and check this with the scheduler. Which runway is empty? Tell me where the runway is empty and at what time this person can land. Now the scheduler goes and check the resource availability. Now it checks, okay, we got runway number 5 empty, and around after 5 minutes this aircraft can land on runway number 5. That response goes back to the control manager. Now the control manager gives this response back to the pilot. That is, that response goes through API to the kubelet. Okay, now the kubelet got the response that runway number 5 is empty and I can land after 5 minutes. Then the kubelet, that's the pilot, goes and lands on runway number 5. All this information, whatever information was shared, this information is getting stored in HCD. That's a database for ATC, where they are storing all this information that this particular aircraft was landed on uh, runway number 5 at this point of time. Okay. Now, what this container runtime and kubeproxy plays in role? The container runtime, imagine all the passengers sitting on the seat. The passenger sitting on the seat, and kubeproxy is nothing but it's a communication which is happening internally between the passenger. That is what kubeproxy is all about. Again, there's a request. The pilot needs to take off. The pilot needs to take off. Now the pilot goes back to the API server, the ATC. The ATC sends the request to the control manager. Using the job controller, the request goes to scheduler. All this communication gets stored in the HCD. Then the information is sent back to the kubelet. Now replace this entire scenario of aircraft and things with real-time scenario application. Now, as your kubelet receives a deployment request that XYZ application needs to be deployed, kubelet will not decide where to deploy. Kubelet will send this request to the master node. The job controller will see, okay, there is a new deployment request. The request will be sent to the scheduler. Scheduler will check the availability, the pod. So basically, this is this container, where this container, on which node the container will be scheduled. Based on that availability, the request will send to the control manager again with all the available nodes, and then through API call, the request will be sent to the kubelet. Now kubelet got the information that this particular container needs to be deployed on XYZ node, and the node, on that particular node, the pod will be deployed. Okay, and all this configuration information will be stored into HCD. And between the between the containers, if you want the communication to happen, that happens using kubeproxy, and the container which gets created, that happens because of this container runtime engine, that is Docker and all. Makes sense? This is how the complete workflow of Kubernetes works in real time. Hopefully you guys will remember the aircraft and the landing ATC scenario in your mind now. Make sense? Anyone, any question, any doubt? Now understood what exactly, how these components interacts with each other, and how the entire processing of creating one single container happens.
I think it makes a bit more sense now. I had a question about the kube proxy. You mentioned that controls the communication. Is that between the pods? I mean, between the pods, or the work nodes, or does it control communication outside of the cluster as well?
Yes, outside cluster as well. So suppose you got worker nodes, like multiple worker, 4, 5 worker nodes. So if you want your containers to communicate, like imagine in this worker node, you got your web servers installed. And in this worker node, you got your database installed. And you want to have the communication channel created. So proxy can help you with that also.
Okay. But what if I was using storage from say like an Azure storage container or file share or something? Would it control that communication as well?
Okay, the storage, that means the storage will be mounted. Like if suppose if you're using a cloud storage, S3 for example. So that S3 basically will be mounted on this machine itself. So for my containers, the storage is they will take look at this container as a local storage. Now for them, it's not a cloud storage. It's a local storage because that will be mounted over here. My storage will be mounted on my local system. Even though it's getting replicated on cloud, that's a different story. But for me as a container, it will be a local storage for me. So they are not going outside anywhere because that storage will be mounted on my local system itself, on my worker node itself. Okay.
Okay. Yeah.
So it's
Thank
not it's not it's not going outside for, because it's not possible. Every time there are so many configuration changes you're doing, and if your data is getting stored outside your worker node, then it may create issue for you. So what we do, how do we do it? We mount it on my worker local system itself. Even though it is getting synced in a real time, the datas are getting synced on cloud. So whatever you do on your local, it getting synced. Remember we did file share in Azure at the very beginning of this course, file share thing. What
you.
was happening? Whatever we were storing on a local, it was getting synced with my file share, correct?
Yeah.
The same concept over here. Okay, what? Okay,
Thank
we
you.
got enough time to set up Kubernetes. So guys, there are multiple ways to set up Kubernetes. We'll go and set up Kubernetes from scratch. Okay, let me tell you, Kubernetes setup is not that easy. All this communication which you see, this API call and all this happens using a PKI infrastructure. That's a public key infrastructure wherein you get public private key algorithm defined, and all the communication happens using public and private key. That is how the authentication happens. Now for doing this, we may require at least one VM for setting up your master node, at least one VM for setting up your worker node. But for practice purpose, okay, for practice purpose, and there are tools available in the market. Like if you want to have a testing environment setup done, then you can make use of Minikube. Now for testing purpose, you can use Minikube. It's a third-party tool. So this will not require multiple VMs, because for testing you can just have one VM and you can set up everything entirely on this one VM. Your master will be running, all these components will be running, and your even your worker node components will be running. So this is Minikube. It's a mini version of Kubernetes which will get installed. Now, can you use this? Is only for testing purpose, guys. Definitely don't even think for production. Testing purpose, okay? This is for your practice. If you want to set up, you don't want to spend money, because it's not a low configuration. You need to have at least 4 vCPU and at least 6 GB of RAM and such configuration what you need for setting up Kubernetes. So it's a big VM which you need to launch. So in such purpose, you can go with Minikube, but definitely this will not be used for production. Then what tool we can use for deploying things on production? There's a tool called kubeadm. The requirement is one 2 VM, wherein one you can set this for wherein your on one VM you will have your master node running, and one VM you will have at least have your worker node running, and you can deploy Kubernetes on top of it. This setup can definitely be done on production also. Now this tool, what this tool they do, they basically take care of all this uh, keys creation, the public private key creation, the establishing communication between all these services. This is automatically done over here. Okay. But if you want to set up entirely by yourself from scratch, even that is possible. But you need to have expertise in managing the keys. You need to have your own CA, that certificate authority. You should be able to generate your own private and public key. You should be able to set up everything by yourself. Then at that time you can go and set this thing up by yourself from scratch. Okay. Now in this course, what exactly we'll do? In this course, will I be using Minikube? Because that is only for testing. So the answer is no. I'll be using kubeadm for setting up Kubernetes. Why I'm using kubeadm? Because in reality, when you start working with Kubernetes, at least you should know how Kubernetes is set up from scratch. But the only difference over here will be I will not use two VMs. With the method, I'll stick with one VM, and on one VM, I'll set up my master as well as worker node. Master and worker both will be set up on the same. Now, how exactly that is done, that is something I'll show you later. Not later, just after this theory. So we'll go and set up this kubeadm. Okay, makes sense. We'll be using kubeadm, not Minikube. Now the minimum requirement is, guys, when you are setting up uh, Kubernetes, wherein you have your master and worker node both, so at least 4 vCPU. That is a minimum requirement, and at least 4 GB of RAM, guys. Nothing less than this. Okay, so this is, I know this will cost, like, because we may have to go and launch a VM on Azure. I know this will cost, but as soon as you're done with the setup, you're done with everything, delete the VM. That is totally fine. Or stop the VM and keep it. Even though if you stop, there are storage and public IP charges which will be applicable, but that's okay. At least we can spend $1 or $2 learning something. Okay. So just keep that in mind, because I cannot have like how we were doing an Ansible 1V CPU and things with Kubernetes, because there are so many components running that one V CPU and 2 GB of RAM will not work. We need to have at least this configuration. At least I can have 2 vCPU at least, but 4 GB of RAM, that is something very much required. Just keep that in mind. Okay, let's go back to the PPT. Now this is what API and all the definition is given. API server is a component that exposes Kubernetes API. HCD is a high available key value store. Scheduler watches for new created pods and assign node. Control manager, there are so many controllers: node controller, job controller, endpoint. There are so many others also, guys. This is just few of the controllers I've added over here. Kubelet is an agent that runs on each node in the cluster. Make sure that the containers are running on a pod. Kubeproxy is a network proxy that runs on each node, implementing part kube service concept. Container runtime, the container runtime is the software that responds for running containers. Okay, now in Kubernetes we don't call it as pods. We don't call it as pods in Kubernetes. We call it as, where do I have space? We call it as, sorry, we don't call it as container, we call it as pods. So in Kubernetes, the application gets deployed inside the pod. So this is a pod for you. Inside this pod, you will have your container running. This is a pod. So in Kubernetes, we create a pod. That pod gets, inside that pod, you will have your container running. Okay, that's not, your containers are not directly exposed. It is called as pods. Pod is the smallest component where your application will be deployed. Even though you're inside your pod, you will, if you go and look into the pod, you will have container. 90% of time you will have one single container running, but based on scenario, you can also have some sidecar containers inside it. So you can find, so if you get a question, can we run multiple containers inside a pod? So the answer is yes. Will this pod will also host an application? The answer is no. This particular container will have some monitoring agents, some logging agent, some networking agents. Those things will be there inside this. Okay, so you'll have only one application running inside the pod, followed by some additional sidecar containers. What exactly this sidecar is, that is something I'll talk about later. But this will be some agent related survey, logging, monitoring, all this services will be there, nothing else. Okay, so in Kubernetes we call it as pod. Just keep that in mind. Are we good? Anyone any concern? We'll go back and set up Kubernetes. We have half an hour, so I think half an hour is more than enough. Okay guys, any concern, any doubt, please do let me know before we jump on and start setting up things. Anyone? No doubt?
Um,
Okay, yeah.
oh, so you mentioned that when you deploy containers into the cluster, it can have
Mm-hmm,
multiple containers in a pod,
mm-hmm,
and it had sidecar services or
mm-hmm,
something. Is that something you're
mm-hmm.
going to show us?
Yeah, when we'll do Istio service mesh, that's a quite advanced topic. So you need to understand Kubernetes well. So we got something called Istio service mesh, in which I'll talk about sidecar containers. What exactly, in which scenario you will have multiple containers inside the pods. At that time I'll show you. But make sure to practice Kubernetes, because if you have any doubt with Kubernetes, there's no point talking about Helm chart, no point talking about Istio, because these are all security topics. Istio service mesh is the network security, how the communication is happening, how do you encrypt the communication between the containers. All this is what we talk about in Istio service mesh. So this is all when you are well versed with Kubernetes. Okay. Yeah. So just to answer your question, yes, we'll cover that. Okay.
So, a quick question.
Yep.
Yeah, you mentioned that in Kubernetes, containers are called pods, right?
Correct.
And then you just mentioned that we can have two pods in one. We can have two containers in one pod. So, are you saying that we can have a container inside a container? Is that what you mean?
Not container inside a container. In a pod, we can have two containers running in. Don't get confused. Let's forget about the sidecar container for now. The application which gets deployed in Kubernetes, that gets deployed inside a pod, and inside the pod you will have a container running. Don't get confused with the sidecar container. That is a different topic. In future I'll talk about. Okay. For
Okay.
now, we have one container which is running inside the pod. Simple. Make sense? And I'll have the sidecar topic later. Maybe next week I'll have that. Don't worry. QVM. So I'm just creating a machine. Image 2004 is also okay for me, but let me go with 1804. Now size, this is important. Now I'll have to go with this B2S, wherein we have 2 vCPU and 4 GB of RAM. Okay, you can go more bigger guys, but this is the least which you can select. So let's select this, because if it goes anything less than this, your Kubernetes service will not run. Just keep that in mind. Okay, let me open all these ports, review and create. Something has failed. Go to network, review and create again. Now this will be passed. This is a glitch. This is a cost per hour, 3.2670 INR per hour. This is not in dollars, guys. This is INR. This is very less. So keep that in mind while you spin up any new VM. Okay, it's getting created. And in my chat, I saw Josh has issues connecting to ACR. So Josh, that is because browser, make sure remove all the cache, try some different browser. If still not happening, come to this part. Do you see this preview feature? That disable all the preview feature from here. Go and disable all this preview feature and then try it. Okay, this is known issue wherein you have all the subscription and everything in place, still it's showing no resource found. So this is very known issue. Remember, we had similar issue while creating Key Vault when we were integrating Key Vault with the project. It's very known. Sometime it happens. Always restart, try different browser, remove cache, and you will be seeing that resource coming up. Okay, try that. Wait, okay, we got this resource created. Perfect. Now let me quickly log into this resource. Mhm. Perfect. Okay, I'm logged in. Now let's go and set up things using Kubernetes. Now we need to go to the official site. Let me close this. Let's go to Kubernetes installation using Kubernetes. What did I put in? Kubernetes installation using Kubernetes. And if you see, you got to the official site kubernetes.io. Let me tell you, Kubernetes documentation is very well written on the official site. Don't go on any third-party website, guys, because they may end up giving you extra steps, extra things which will make no sense. Always, if you need any help, any assistance, always go and refer the official website of Kubernetes, which is very well written. Okay, so this is where I'm going in right now. If you see, I'm going to the official website of kubernetes.io. And this installing kubeadm. So this is the tool which you need to install first. Now this is what the requirement before you go and do anything. This is the compatibility is Linux host. You cannot do it on Windows, guys. Keep that in mind. That's why I went ahead and created Linux machine. 2 GB or more RAM. 2 GB it is telling, but 2 GB is very less because what I want, I just don't want to have my master node. I want to have workers also running on the same machine. So 2 is very less. You need to go with 4 GB of RAM. Okay, keep that in mind. And 2 vCPU. And all these are Mac. So this is okay for now because we don't have multiple machines. So this is not unique host name, MAC address, and this is not applicable for us. Now coming down, these are some prerequisite check require ports. So that's why I've opened 443. So my 443 is already open right now. Now it is asking you to install container runtime. So you need to have a container runtime. That was a requirement, correct? Prerequisite. So you can go. So Kubernetes supports multiple container runtime. So if you go to this documentation page, I clicked on the container runtime. These are the runtime which Kubernetes supports. It supports containerd, it supports CRIC-O, it supports Docker Engine, it supports Mirantis container runtime. Now, previously Docker runtime was the default runtime engine in Kubernetes. Now it is not there. It is containerd. This got changed around 2 months back. Okay, previously it was Docker was the default runtime, but now it got changed. But that doesn't mean Kubernetes doesn't support Docker. It's still supporting Docker. Now for installing Docker, you can simply click on this. And do you see this link? Install Docker engine, click over here. Now this will take you to the Docker official page. Again, I'm going to the official page, no third party. And which machine we have? We got Debian, correct? That's a Ubuntu machine which we have. This Ubuntu over here. We got Ubuntu machine over here. Which all Ubuntu OS supports 1804, 2004, 2204, 2210. So we got 1810, 1804, correct? Come down. These are the steps which you need to follow to install Docker. Now this is the proper way we are installing Docker with all the prerequisites, which is required for Kubernetes. Let's go and run this commands. Now the first thing, so Kubernetes installation is, again, I'm telling guys, it's not that easy. At once, you'll not even come to know what all things we have installed. So go step by step, follow the official documentation, go step by step. Done. Now this is the key which we need to add. Copy this. Done. Then set up this repository locally. Done. Update your package again. You should see the Docker repo link now after this. If you're seeing this, then you're in good shape. Now this is along with Docker, Docker CE, Docker CLI, Container D. Container D is still required because that's a default runtime in Kubernetes now. Okay, and these are the extra plugins and compose and everything is required. So I'll go and simply get this. So there are so many things we install while we are doing Kubernetes. That's why I said we need to have a bigger configuration, and definitely you cannot do all this on Windows. Windows is not capable of doing all this, so definitely you cannot do. So you need to have Linux machine for doing all this. If you want to do it on Windows, you need to have a Oracle VM created on top of it, and on top of it you need to install Ubuntu or Linux machine, not Ubuntu and Linux machine basically. So what are we doing? We installed Docker. This is the Docker installation is going in right now. Okay, how do we verify if Docker is running? I can simply go systemctl status Docker running, perfect, and I got container D also installed. So systemctl container D, we got container D, perfect. Okay, you can run your Docker commands now. Docker ps, nothing is running. Docker ps -a, nothing is running. Perfect, looks good. One part is done. Let me ping you this part. Keep it as first link, name it as first link. Okay, this, close. Come back to your official page again. So your installation is done. You have installed container runtime. Now come down. If you come down, this is a step for installing kubeadm, kubelet. Kubeadm is a tool which will set up a bootstrap your cluster. Kubelet, the component that runs on all the machine in your cluster and does things like starting pods, starting pods and container. kubectl is the command line utility tool. How do you work with Kubernetes? So Kubernetes, or how do you pass on the commands? How do you send the API call? All this happens using this kubectl. kubectl is a command line utility tool in Kubernetes which will help you deploy an application, which will send the request to the control manager that I need to have a application deployed. All this communication happens using this kubectl. Without kubectl, there's no communication. So all the API calls happens using this kubectl tool. Okay, so these are the three important components which we need to install. Let me share this link. Mark this as link 2. Okay, link 1 for Docker, link 2 for setting up kubeadm, kubelet, and kubectl. Okay, how do we install this? Log. This is how. Let's run these commands. I've already done the update, so there's no need of doing update again. Done. Now let's have this key downloaded. Done. Let's add this repo link. Let's do an update first. This is update which we are doing. Now this time we are using apt-get. It's the same thing, no worries. Now if you see this, you got Kubernetes added, the link is added. Now the second thing is this part. This will make sure that everything is installed. One important, very important thing, when you're installing this kubelet, kubeadm, and kubectl, all these three tools, tools should share the same version. All the three tools should share the same version. If any of this, if any of the version is mismatched, there's a great chance that your Kubernetes infra will not work the way you want. That's why if you see this next command, apt mark hold. So this is what it is doing. It's making sure that these tools, these three tools are not automatically updated. So when you run this command update, there's a great chance. Then when you run an upgrade command, there's a great chance that all the new versions of whatever applications running will get updated automatically. So this hold command, what it will do, it will hold all these three tools and make sure this is not automatically updated. If you want to update this, you need to go and manually do it. Automatically, it will not be done. So that's why we always prefer running this command and marking this three tool and holding this three tool. Basically, kubelet set on hold, kubeadm set on hold, kubectl set on hold. Now, if you want, you can just go and look into this versions and you will find out the versions are same. Kubelet version failed. Kubelet version 1.27. Okay. Kubeadm version 1.27. What else is there? Kubelet, kubeadm, kubectl. Kubectl version. No, this flag is not accepted. Kubectl version 1.27. See, all these are sharing the same version. So all these three tools should share the same version. Just keep that in mind. If any of this version is mismatched, there is a great, you may end up getting some issues. At once, if the kubectl version is one version lower or one version is higher, that may work, but that is not recommended. Okay, so this is done. You got your kube. What all things you have installed? Docker runtime, containerd, kubelet, kubectl, kubeadm. Now the next part is use kubeadm to create a cluster. So this control plane and worker node is known as cluster, guys. So let's click on this link. Again, mark this as a third link. Okay. Now there is, if you come down, initializing, this is the steps which we need to follow. Initializing your control plane node. Okay. Now this command will go and initialize your master node. That's your control plane node. Remember the diagram? So the master node, the control plane node, this is this thing which will get initialized. Where's my diagram? This part will get initialized. Okay. Come back, just run the command kubeadm init. Okay, I got some error. Error is container runtime is not running. Okay. So when I did a kubeadm initialize, this is the error which I got. So in order to fix this error, what you need to do, come to this folder, etc container d. Wait. Just give me one quick minute. etc etc container d. Why this thing is not coming automatically? This, and there is a config file over here, config.tom. This is something we need to remove. So this is the command which I'm executing, rmrif containerd and config.tool. Done. Now after this, go and restart the containerd services. Done. Make sure the status is running, the container is also running. Perfect. I'm just copy pasting this commands for you guys so that you keep remember these commands. This is what you need to do. These two commands. If you get the error which I got, if you get that error, then run this command. Make sure you are logged in as a sudo user for doing all this. Okay. Okay. What else? Now let's go and run the init command again. Now see if I'm not this time I'm not getting any error. Wait while this is getting set up. I'll just come back. Okay. So if you see this, my initialization was done successfully. These are the commands which I need to exit out of sudo user. I need to run it as a normal user. So just keep this command over here for now. And alternatively, now this is my master node got set up, guys. My master node component got set up. If you see this, kube proxy and everything got set up. Now, if you see this command over here, kubeadm join, this command. Now, if you want to have a worker node, the exact same thing, whatever we did till now, the exact same thing you need to do on the worker node. After running all those commands, you need to run this command, this kubeadm join. What will happen? This master node will register the other VM as a worker node for you. Now, if you want to do something like this, such setup, then you can definitely go and create one more VM with the same configuration, do the exact same thing, the entire step, whatever we did till now, and at the end, run this command, kubeadm. The only thing you don't need to do is kubeadm init. That init part you don't have to do. After doing all the setup, just run this kubeadm join. The only part you don't have to do run is kube init. That's it. Kubeadm init. Make sense? But I don't want to do this. The reason I don't want to do this because I'll be using the same VM as a master node also, as a worker node also. So I'll just ignore this part and I'll just exit out of it from my root and I'll just execute this command. This commands. Okay, perfect. Now I got Kubernetes installed successfully on my system. Now if I go back and run this kubectl get node, do you see? I'm getting my node information. Now I'm running with the ad hoc commands of Kubernetes, guys. So all the ad hoc command, all the communication happens using kubectl. So kubectl get nodes will get you the node information.
Can I ask a quick question?
Yep, tell me.
So why did you exit out of the root to run the command? What's the reason?
Okay,
Since you
so
did
if
all of this installation using doing it as a root, and when it's time to run this command, you exited from the root.
correct. So this is basically if you see this command, what exactly it is doing, it is creating a hidden file .kube and it is copying the configuration, the admin. So everyone will not should not use admin credentials. Basically, that is what Kubernetes tells you. It's copying the admin config inside this config file and it is giving all the privilege. So the user, wherever you're running this command, it's giving that particular user all the privilege to run administer Kubernetes. Because if you directly go and do it from the root, there's a great chance you end up messing up with configuration. And at that time, if you mess up this config file, your entire Kubernetes cluster is gone. So that is what, to be at the safer side, Kubernetes is telling you, boss, exit out of root, go back and set up your own config and start working from there, not from the root. That is what Kubernetes is telling you. But can I do directly, can I work from the root? The answer is yes. No one is stopping me. But that is not the right way of doing.
Okay, that's what I want to understand. I know about the root that it's an administration. Only the administrator can do that.
Mm-hmm.
I just wanted to know if you can still do it.
Yes, you can still do it. Yes,
Okay.
you can still do it. There's no
Got it.
stopping. Yeah,
Okay. Thank you.
no problem. Okay, so now one issue, if you guys have noticed one thing, the status not ready. Okay, now why this is not ready? If you want to know more, then you can basically do a describe and you can know more about this particular node. So you can have a command called kubectl. Don't worry about these commands. I'll share these commands with you. Describe node, this node. Now, when you go and describe, you get detailed information about this particular node. These are all the events which is happening inside the node, like kubectl and things like that. These are all the details. Do we see any error anywhere? There is an error. Network plugin not ready. Message network plugin error. CNI plugin not initialized. So guys, this is because your network proxy is not installed. So you need to go and install a third party network proxy on your Kubernetes cluster. Now you will say, where are the services running? We spoke about there are so many services running. Where are those? So if you go and look into namespace, there are multiple namespace which got created. Default namespace is where we are right now. Namespace is nothing but it's multiple partitioning done, and all your services are running in particular namespace. So all your services are running in Kube. All these three namespace is getting used by Kubernetes. You cannot do anything inside those namespace. This is getting used by Kubernetes, guys. Just keep that in mind. The only namespace which you can use is default namespace. But if you want to create your own namespace like development, production, QA, and things like that, if you want to have such segregation done, that is something you can do it later. But for now, this three is system namespace. No one uses it. At Kubernetes itself, it is using. Now, if you go into this namespace, if you run the command kubectl get all, and then if you use the namespace kube system, this is the command. Don't worry about the command. I'll share the documentation wherein you will find all these commands. And if you see all the services. Do you see how many pods are running? There's so many pods are running. See this. You got your HCD, you got your API, you got your control manager, you got your kube proxy, you got your scheduler. You have everything, whatever is mentioned in my PPT. Okay. Now, one important thing, you got something called core DNS. What this core DNS service is, this is basically maintains the DNS mapping in your Kubernetes cluster. So your DNS mapping, IP allocation, all this is done by this core DNS. Now this core DNS thing is pending right now. Now this is because you don't have any core DNS service running. So by default, you don't get core DNS. You need to have those core DNS controller installed on your Kubernetes cluster. By default, you don't get it, guys. Just keep that in mind. By default, you don't have it. So you need to have a third party. So there are multiple core DNS CNI controller which is supported by Kubernetes, which you can go and install on your Kubernetes cluster. That is why your node is not ready. You cannot do anything in the node. Let's go back. Now, do you see there's an option of install network pod network add-on? This is basically you're installing the CNI. Okay. Let me see the right link, which I can go directly, because finding that is a big task, getting that list. Okay, let's click on this. Okay, do you see this container network interface? This is something cluster DNS, that's core DNS, which we need to install. We'll get a list, complete list of core DNS. Network models, see the list of add-ons which Kubernetes supports. Click over here. This is the place how to learn network model. See here. This is where we need to know. Go back. Don't worry, I have it in my bookmark, but I want to show you how it is, how we go and find it through the official documentation, because things keeps on updating. Complete waste of time. Let's go to network policy. Network will implement network plugin. No network plugin. Okay, forget about this. Don't have it. Installing add-ons. Okay, this is the one. Now this is the link, guys. So this is, you'll find it from the official documentation only, but somehow I was not getting it. So I'll just sharing this link. This is the fourth link. Keep in mind. Now these are the add-ons which network add-ons which Kubernetes supports. It's a big list. ACI, Anteria, Calico. These are all add-ons. It has its own benefits. It has its own feature, and this is something you can go and use it. In my case, I'll be using the last one, the VNet. This provides networking and network policy, will carry on working on both sides of network partition and does not require external database. So this is the one which we will be using, VNet. Click on this VNet. This will take you to the official documentation of VNet. And if you come down, this is the command which you need to execute. Let's run this command, execute this command. Now, if you see this, it has created multiple things. Cluster roles, service account, cluster role binding, RBAC authorization, role binding, daemon set. So there are multiple things it has created. Now, if you go and look into the command again, kubectl get all kube system, you will find this kube DNS. And if you see this daemon set VNet over here, and if you go at the top, do you see this container creating now? You got this VNet, and if you see there is a container creating. So just in a while, you will see your status of your node to be ready. Kubectl get nodes ready. So your master node is ready now. On this master node, can you go and run any application? The answer is no. This is your master node. By default, on your master node, you cannot do anything. It will not run you, it will not let you deploy any, what it will not let you, it will not let you deploy any pods. By default, it will not let you do. Then how do we do it then? Okay, now how do we do it? That's a different story. Let's go and see how exactly we can do it. Now, if you want to see if there is any running pod on your default namespace, so default is the only namespace wherein we can create pods. But if you see, I have nothing right now in my default namespace. Can I create? It will definitely let you create, but it will not assign any resources to you, basically, because by default you cannot create anything on master. Let's see that. Let me run a Nginx web app, kubectl. Let me just run a Nginx run. Let me give the image name as Nginx, and let me go and name it as web in -nginx. This is the name of my pod. So basically inside the pod, I'm running a Nginx container. Let me see if that works. It's showing created, but if I go and see this kubectl get pods, do you see it's pending? One pod 0 out of 1, it is pending. Now if you go and how do you debug? Now this is your debugging capabilities also. How do you debug? You can look into the events, kubectl describe pod and the name of the pod. Now you can see the event over here. Now event is failed scheduling. The reason is default scheduler. 0, 1 nodes are available. One node has untolerated taint. What is this untolerated taint? Now by default, the master node is tainted. Okay. So tainting is a concept in Kubernetes, which I'll talk about that later. But by default, it is tainted. Just remind me on Monday. I'll talk about taint and tolerance. But how do I create my pod? Because what did I say? I wanted to use this master node as my worker node also. So what we can do, we can go and untaint. I'll talk about this concept taint and tolerance later, guys. But for now, let me go and untaint this particular machine. So this is the command kubectl node all, and you can go and run this command, and you can go and untaint your paste. Yeah, the role is control plane. I was just verifying the role name is control plane, and now I'll go and untaint. Untainted. Now let's wait for a while. Now run the command kubectl get pods. Do you see this is running now? So taint and tolerant is a concept. I'll take 10 minutes more for that. Remind me on Monday, we'll cover that taint and tolerance concept. But by default, your master node is tainted, so you cannot create anything on top of it. It's only system can create, Kubernetes can create. If you want to create something, you cannot do it. So that's why I've untainted it. Now, if you see, my pod is running. Perfect. This is how you will be setting up Kubernetes. This is a bare metal Kubernetes which you set up. We have set up Kubernetes from scratch, starting with running Docker runtime, containerd, kubelet, kubectl, kubeadm, followed by initializing your Kubernetes cluster, bootstrapping your Kubernetes cluster, then installing core DNS, that's VNet, and then untainting your master node and deploying a Nginx web server on top of it. Okay, so many things we did. You got the complete weekend with you. Kindly go and practice this. Try setting up Kubernetes not just one time, 3 times. Make sure you are well versed with Kubernetes setup. And these are some basic commands. I'll walk you through these commands again on Monday, and we'll see everything again on Monday. Okay, I'll walk you through with ad hoc commands. How do we deploy? Then we'll deploy a Nginx. Then we'll deploy a custom application on Kubernetes. Remember, we got custom application into ACR now, the .NET application. So even if you want to deploy the .NET application into Kubernetes, how exactly that is deployed, that is something I'll show you. Okay, so that's it for today. It was a big session, and there are so many things we have covered today. Make sure to practice, because going forward, using this cluster as a base, I'll be doing many things. Next week, I'll be doing many things. And on this cluster base itself, I'll installing Helm also. On this cluster base itself, I'll be installing Istio service mesh also. And on this cluster base itself, I'll be installing all the microservice monitoring tool, such as Kiali, Prometheus, Grafana. So this is the base which we will be using. Post that, I'll just give you a walkthrough of AKS, because if you know Kubernetes bare metal, AKS is not a big deal. Okay, are we good? Anyone any questions, any doubt? Please do let me know, or else we can wind up the call for.
I got a quick question.
Yep.
Hope you can hear me okay.
Yeah, I can.
So I did create an Azure Container Registry,
Mm-hmm.
and I was concerned about the cost. Is that something we can keep until Monday without getting charged, or do you advise that I delete it?
Just delete it, because it will definitely, even though we are taking the very basic uh, ACR, we took very basic one, but yeah, talking about cost, it will still cost you not much, less than cent, like 5 6 10 cent, but still that is the cost. So yeah, delete it. On Monday, I'll show you. We'll create an image again, and we'll push the image using this Kubernetes cluster itself, because we got Docker and everything already there in this. So we can use this machine for pushing the image. So on Monday, we'll create an image again. Don't worry. Delete it. That's okay.
Can you hear me okay?
Yeah,
We think you heard that.
perfect. Perfect.
Sorry, I had one more question. Sorry. So if we create a virtual machine and we're running Kubernetes on it,
Mhm.
um, if we shut down the virtual machine but still keep the instance, do we get charged as well?
Yes. So there are other components along with your Kubernetes cluster. You got your public IP, you got your storage attached to it. So yeah, you will get charged for those things. Not
Gotcha.
much, but yes, you will get charged.
Okay, thank you.
No problem.
Make sure you stop it rather than just like log out. It'd be cheaper.
Yeah, so if you're stopping it, it'll
Okay.
definitely be cheaper because you're not using the compute. But yeah,
Okay.
if answering to your question, is there a charge? Yes, there is a charge, because it's not just the VM. There are so many other components, if you go and see, attached to your VM, which will cost you, definitely.
Okay. Sounds good. Thank you.
No problem. Thank you very much, guys. Thanks for your time. Let's meet up on Monday and let's continue with this topic. Bye bye.